This is part 2 of our interview. We do our deep dive into the company and market and answer questions from our audience. Thank you. Good day. It's Wednesday, April the 21st. I'm Martin Gagel with Radius Research. Today we're joined by Mark Saxon, CEO of Medallion Resources, MDL on the Venture Exchange. I want to start off with discussing Monazite itself. You kept talking about the waves, and this is a little kind of beside the point, but I'm just kind of curious. Like, how is it formed, or why is it? It clearly seems to be along the coastline. Sure. You talked about waves, so it's some ocean dynamic that's creating this.
For sure. So we're talking about a class of deposits here that we call heavy mineral sand deposits. So if you imagine when a rock breaks down and weathers, all of the soft minerals dissolve and the hard minerals don't. The hard minerals turn into small sandy grains. So the most common one obviously is quartz, but alongside the quartz there are some other heavy minerals that also have not dissolved over the time of weathering and rainfall. So those minerals, I guess, sit in the soil, and then at some point, as the coastline changes, as waves and wind and rivers develop, those end up in the rivers, and those small heavy minerals like sand are essentially concentrated into the rivers and end up on the coastlines progressively over tens or hundreds of millions of years. So all of the heavy minerals are dense and heavy, and so they travel together by the wind and wave action, and there's a natural sorting of the minerals that happen. So there's a whole range of locations around the world where those heavy minerals have concentrated into, they're called strand lines or dunes, often around beaches, sometimes in rivers, where all the heavy minerals are together. And so maybe those deposits have 10% heavy minerals, and then the rest is say quartz of no value. So when the market for zirconium and for titanium utilizes those sand deposits, they're very soft, they don't require blasting, they will be dug up very simply. And then they put them through typically say a gravity circuit to use that density, to use that weight difference and separate the heavy minerals from everything else. And so within that process, monazite is another heavy mineral. So it follows through that process and is concentrated. So if you imagine, we all know what, I guess in gold prospecting, gold panning, it's exactly the same kind of process where the gold is the heaviest mineral in the pan. You shake it around and you end up with a tail of the gold in the pan. Exactly the same thinking, but in this case, it's other heavy minerals that are being concentrated in that pan or in that system. And so, today, the zircon, the titanium minerals are going to customers around the world, particularly for paint products. The monazite is not going to a customer. So the customer just hasn't existed in the Western world or at the ex-China world. And so maybe there's Chinese customers and a lot of material gets sold into China. Otherwise, it's not being utilized. And so that's an opportunity for us to take that sand and process them.
How common is the monazite around the world? Is each deposit pretty similar, or how much variance is there between locations?
There will always be a small amount of monazite in every deposit. Whether there's enough to recover is the question. So it will always be there in some form. We're doing the work and we know where the best deposits are, but really it's a scale. So there's always something, and some have a lot more. So we've identified, I guess, half a dozen locations that are ideal. So it's always there. I guess the other thought is how much neodymium praseodymium is inside the mineral sand monazite. So the ratio of the rare earths inside the monazite changes. So we want to see more NdPr inside the monazite. That affects our economics. And I guess the other driver, and it's something we need to talk about, is the radioactivity. So there's always a bit of uranium and thorium associated with the monazite. And so the lower numbers for those is better, unless we're in certain circumstances where if high is good, then they can also be a product and add value as well. So there's some metrics there that we understand, and we understand how it varies in the processing. But really, wherever we go in the world, we're able to take the monazite and we're able to process it. It goes through our process very well.
There's a question here: is your monazite igneous or a sedimentary based?
So I guess I can say both. So it would have originally been igneous. It's now being weathered out of that igneous rock, and it's ended up in the sand. So yeah, it's sitting in a beach. Yeah, imagine the dunes of a beach, and yeah, with 0.5% monazite within those beach dunes. So alongside the monazite, there's other more valuable minerals. And so the other more valuable minerals are being concentrated, and that in the same process concentrates the mineral sand monazite. And yeah, so, and that's happening every day around the world. Yeah, very, very major mines are doing that to extract the other minerals, not necessarily the monazite.
And your extraction process, does it, can you talk, like, is it like a multi-step process where there's some preliminary where extracting the monazite out from the rest of the sands, and then your process separates the monazite for the good stuff, or where is your process in the sort of the mineral supply chain there?
Yeah, so we'll be customers of say a 90% monazite concentrate. So we will receive a brown sand which contains 90% monazite, because that is done at the mine site of the mineral sand miner, and so we're a customer for that. So when we receive it, it's essentially ready to pass straight into our chemical process. So it passes into the chemical process and is dissolved within the process that we are applying. And we extract the rare earths, we extract a phosphate product, and we move those through and turn them into the valuable products. So yeah, the monazite, as it enters into our facility at the front door, will be just like any other chemical, I suppose. So yeah, a very predictable chemical that comes in. We know exactly what we're getting, and yeah, we bring it into our process straight away.
And so the radioactive material, the uranium or the thorium, that is part of the monazite. So you're separating that. And if there's enough, or if you're in the right location, you could sell it, it'd be a credit. If it's sort of an unfriendly part of the world, then it could be a liability where you've got to figure out a way of dealing with it. Selling it, I guess, is relatively straightforward if there's a customer. What do you do if there's not a customer for it and you have to dispose of it?
Sure. And yeah, dealing with radiation, and for every mining company, dealing with waste is a major part of what we're doing. And I guess that's how we look at being more sustainable. So for mineral sand monazite, it always has a little bit of uranium and thorium. That's yeah, and for most rare earth projects around the world, they're dealing with some level of radioactivity, and that's okay as long as the process is well understood and planned, and you have enough data to support your decisions, which we certainly do. So it really depends on the jurisdiction, and so working in jurisdictions that are familiar with uranium and thorium, familiar with radiation management, then there is reasonably simple strategies. So yeah, we can certainly turn them into a product if needed. We can put them into a format where they're suitable for long-term waste storage. We're talking about really small volumes here, and so we're not talking about we're talking about things that are less than medical waste in most countries in terms of volume. So yeah, they're very small numbers. But yeah, we have strategies to yeah, in various locations. But I guess the key thing is to choose the right location. So where we will place our hubs, our process facilities, in locations that are appropriate for the handling of the radioactive materials. And that makes life much easier. And when we're dealing with authorities, we need to be dealing with authorities that have skills in radiation management and permitting. If there's a uranium mining industry already there, then absolutely that makes a very big difference. Yeah, if there's nuclear power there, absolutely that makes a very big difference. The country has the skills it needs to make the decisions.
All right. With your process, you've recently licensed the LADC technology from Purdue University. Is that the entire process, or is that sort of the last step in your refining process? Because I know you've been working and investigating in Saskatchewan, other places, some processing technologies. Can you elaborate on the LADC?
Yeah, for sure. So yeah, so we now have I guess two sides to the business. So the first side is what we call the Medallion monazite process, And so we've been working on that for about 5 years. Yeah, loads of test work, loads of expenditure, and that's taking the brown sand, dissolving it, and producing a what we're calling a mixed rare earth product. So where all of the rare earths are sitting in one powder. That powder then, I guess, yeah, originally the vision was to send that powder out to a third-party separation company, and yeah, allow somebody else to do that. And but I guess when we started to dig into that rare earth separation market, we saw there really was no clear winner. There was no partner that had really done well that yeah, we had faith in. So we went round and we spoke to all those separation partners. We identified a few that that had potential, but we then came across the technology that was happening at Purdue University. And so yeah, a scientist there, a lady named Linda Wang, has been working on this for about 10 years. With Department of Defense funding and other funding out of Purdue University on research projects. And so she's developed a system that accelerates and improves chromatography, which is a reasonably well-known system. And by using a range of factors that are proprietary, she's able to get something like 100 times more efficiency out of the system. And so, yeah, she's done amazing work. And Purdue is well known for chromatography. It's well known for pharmaceutical purification and separation. That's a big part of their research. And so this is a small step out from what's been done in pharmaceuticals. And so what we're talking about here in terms of volume is tiny compared to the pharmaceutical industry. What we're talking about in terms of purity is we're relatively impure, obviously, versus the pharmaceutical industry. So all of those ideas and technologies and processes already exist through Purdue University. What we're doing is taking it to a new application. So we have the license to apply it to both our Monocyte process, but also to any other third-party mines and waste materials facilities that exist around the world. So yeah, peers and competitors can certainly be part of that. And so we're talking to some of those at the moment. So yeah, anything that's not recycling and not coal sourced, is in our purview to be able to apply this technology.
So would you be able to apply this to regular mine tailings for whatever gold, copper, whatever other kind of mineral processes?
Yeah, theoretically it will have other applications. So it really depends on the incumbent technology and how much that incumbent technology needs updating and change. So yeah, we know the costs for what we're doing in the rare earth sector, and we compare that with the existing incumbent technology, and we know it's extremely cost competitive in that market. We haven't been out to take a look at those other markets, and yeah, so we need to, yeah, that's another research project in itself.
The LADC process, how proven is it? Because when any kind of processing technology goes from the lab to a bench and sort of bigger, sometimes they don't scale particularly well. How much scaling risk is involved with this?
Yeah. So I guess when we consider that, there's the two sides of the story. So one is the chemistry, and one is the hardware and the infrastructure around it. So Purdue University has worked with much larger systems than this. Very similar architecture, I suppose, in terms of how to operate chemistry on a large scale. And that's often where the challenge comes up, is that how do you go from a litre a day to a litre a second? Is really quite challenging. So Purdue's done that on many occasions in many other markets. So we're very confident about that. And in fact, there's a key person involved in the story who has implemented chromatography in many locations and on many scales. So we're very confident of that. The other part's the chemistry. And so Linda's been working on the chemistry for 5 to 10 years and has optimized that chemistry extremely well. She's developed, and I guess some of the magic sitting behind it is a mathematical program and chemical program sitting behind it that allows accelerated research. And so we're going through that process now. We're extremely confident from the results we've seen that it will scale. Infrastructure wise, absolutely. Chemical wise, we're at, say, a TRL 5 out of 9 or something like that, is where I think we see.
And this is what you're talking about here. This is all about the separation. Because you do processes, 2 steps in the processing. You extract the monazite from into a high purity monazite, and then you separate that into the different rare earth elements.
Yeah, so we extract the rare earths from the monazite, and then we separate the rare earths from a rare earth powder from a rare earth carbonate. So those the Medallion monazite process we've developed ourselves internally. The LAD process we're developing in combination with Purdue, and have that licensed. So in the case that that the Purdue technology didn't work, or we found a better system, then we're able to divert our materials into that system. But we're seeing at the moment the two processes fit together extremely well. And in fact, one of the great advantages is instead of converting it into a powder, we just connect the 2 processes, and essentially it's rare earths in solution going straight through into the process, and that allows us to remove some of the steps in our processing, and that's a thinking called process intensification, where you reduce the complexity of a system and remove as many steps as you possibly can, and that saves costs and chemicals, and it allows far more sort of secondary use of materials, a lot less waste. Your recoveries stay high, and so that's our aim, is to connect these things into one system. And essentially, it's going to be a plug-and-play system when we take it to a new location, where we're able to say, what's the tonnage of mineral sand monazite? All right, here's the build-out for that facility. And then if the market allows it, then we scale up that system, and we can progressively scale as the market allows.
Given there is separation technology not as efficient and as friendly, and there is and the extraction, the rare earths extraction technology is out there as well. You seem to have improved that, but rare earths is a valuable commodity. Why haven't other monazite? Why haven't other people, like, there are all these big piles? It's not like you're not really a mining company or a processing company. Why haven't other people exploited these big monazite reserves around the world today?
The original source of rare earths was mineral sand monazite. So that was really the foundation of the industry, was mineral sand monazite. And then I guess the industry became more Chinese, and so there's not a lot of mineral sand mining inside of China, and the Chinese system converted to use their own resources, which is again it's a byproduct from a very large iron ore mine in Mongolia, which is called Bayanobo. And so Bayanobo, where most of our rare earths come from, is an iron ore mine, which has as byproduct rare earth metals. Exactly the same thinking of what we're doing with mineral sand monazite is taking a byproduct. And I guess there are companies using it. They just happen to be Chinese companies. So there is a lot of mineral sand monazite that is going into the Chinese market, that comes from all parts of the world, Australia included, the US included, Africa included. Mineral sand monazite from all of those locations is being sold into China at the moment, and adding into their existing processes. So they're mining less of their own materials, and they're taking external materials for processing, which is it's a great business model, and it's smart, and it's what we should be doing as well. It's highly resource efficient. It's the lowest CO2 approach. It's a very economic approach. It's just something we should be doing in other locations as well. And if countries want to build out downstream industries using rare earth metals, then this is a super way to do it, because getting access to a whole mixture of materials gives them a whole lot of downstream opportunities. Exactly the same way as the Chinese are optimizing that system and really getting the downstream value add from access to the raw materials.
You're in the process right now of doing detailed economic studies on it. Do you have you must have done some preliminary stuff on a back of a spreadsheet somewhere. Do you have any sense of the cost, the economics? Like, is this a big CapEx project? Any sort of thumbnail kind of guesstimates as to what the CapEx would be involved in a system?
Yeah, for sure. Yeah, and so at the moment we're just about to complete what we're calling a techno-economic study, and it's we can't use the language of scoping study, pre-feasibility, feasibility, because we're under the NI 43-101 system, and what we're doing doesn't really match with that system because we're not mining an individual project, a resource. We're much more like, I guess, a technology issuer that the mineral sand monazite is like a chemical that comes into our process. So it's an economic model. So it's got the engineering component, it's got the financial component, it's got the life cycle assessment components. So we know what we require physically in terms of inputs, outputs. We know the cost, and we will know the carbon footprints of everything we're doing as well. So it's a very holistic model that we're building. And that is being built so that we can essentially drop it into any location that we want to and do a comparative study on which location is the best, where we want to optimize our process. Obviously we've done lots of internal modeling and studies on that. We know the numbers, plus or minus, and but at the moment this is now being done externally with a third-party provider, independent consultant, and we're hands-off with that. So yes, I know the rough numbers. It's about it all depends on the scale. We're looking at $50 million US kind of level. It makes us a highly relevant supplier in the rare earth market. So the numbers are really quite small, and that's because we don't require mining. We're going to be putting our facility in a place where the infrastructure already exists. So where the chemicals exist, where the power exists, where we've got access to good transport networks, where we've got access to people. We're not going to be, we don't need to go to northern Canada or a remote location in Australia. We'll be in a place where that infrastructure already exists. And so that is a dramatic cost reduction for us. And we're really quite predictable. We know what a ton of mineral sand monazite is selling for today. And in fact, if you jump on Alibaba, you yourself can buy mineral sand monazite tomorrow if you wanted to buy some. And I'm not sure if you'd want it delivered at home, but you can certainly buy it. And so it's in the market already. We have a network and a marketing system where we keep an eye on that market. And so literally we can buy that material very, very quickly. So that's taken out a whole risk part in terms of the mining operation. And so when you think about rare earth mining in particular, you think complexity, you think difficult processing, difficult projects, difficult locations. Mineral sand monazite is not that. It's in fact it's the complete opposite. It's a really simplified system in a complex market, and I think that's why it's going to work. And so the Chinese have done it for a long time and made it work really well. Medallion will be doing it. Energy Fuels in the US, we've seen them with a smart business model as well. And so I think it's a great way to be producing rare earths environmentally efficiently, resource efficient, low cost, and really very competitive for the long-term view of the market. Whatever the prices do up and down, it's going to be robust. And it's able to scale as the market grows as well. There's far more mineral sand monazite than what's required by ourselves or Energy Fuels or anybody else. There's perhaps 10 times more at the moment being traded than what we need as a business. So there's no limitation on that side.
So your system doesn't have to be too close to the actual sand deposits. You can be, but you're going to be shipping a lot of sand, which is relatively heavy and expensive. But still, the economics, there's better cost savings and carbon savings, call it, if it's closer to infrastructure as opposed to close to the actual deposit.
Yeah, we have a few different business models there. But I guess, first of all, mineral sand monazite, when it's been processed to 90% monazite, which is the product that we'll be taking, and that's all done at the mine site. So monazite is 60% rare earths. So it's a really, really rare earth rich material. So you're not shipping very much waste around the world. Really, all you're shipping is rare earths. There's really not that much else. So half the product is rare earths, which is really high grade. If you look, for example, at what Mountain Pass is mining in California, so that's about 7 or 8% total rare earths. In Australia, Mount Weld, they're mining at 10% rare earths. So when you've got 50% rare earths in your feedstock, it's a lot, and so it can handle the transport in terms of the economics. I guess if it's a large project, a large mineral sand mining project, then being close to that project, where we have the single source, absolutely that makes sense. Yeah, there's no point having material from Australia go to Canada or somewhere like that. And yeah, nothing against Canada, but just the remoteness and the double handling and things, and it adds the carbon footprint, and it adds the just the complexity of it.
And Australia's got sufficient infrastructure as well to
yeah, exactly.
set up a system.
Yeah, exactly. So I guess there's two approaches. So either we put the our process next to the mine, or we put it in a location that is an optimized location where we have all of those conditions that are suitable. So radiation management, yeah, transport networks, access to chemicals. And then we bring in multiple sources of mineral sand monazite from that region. And so we're looking at both strategies, both are smart. Yeah, in fact, being a technology provider to an existing mineral sand miner is a smart approach as well. And yeah, so we can take that view. So it really depends on horses for courses and the scale of mineral sand monazite that's required. When we kind of think in modules at the moment, so our first module looks to be, say, 10,000 tons per year, something like that. And that makes a pretty good business. And yeah, so if we're in, yeah, I know of 5 mineral sand mines around the world that produce double that amount of monazite. So yeah, there's many choices about places we could be, yeah, to get access to that monazite. There's no real shortage of monazite. It's more about being in the smartest location, from an economic point of view and from an environmental point of view as well.
So with the LADC process, you could set up standalone separation facilities in Malaysia or other places in the world where you take other people's rare earth feedstock and then separate that as well. So that could be another
theoretically, yes, but yeah, that kind of toll treating approach, I suppose, that you're talking about. Yeah, I guess yeah, our preference would be to to assign that directly to a partner or a company that's doing their own process, because it really does work best. And if you think about it from a environmental perspective and life cycle analysis perspective, if you can keep everything in solution and go from one process to another, without any gaps, without any transport, then yeah, that really is the way of optimizing and reducing the footprint of rare earths. So that really is our preference. So if there was a mine site or a location, we'd much rather put the technology on that mine site and and allow them to value add, and obviously licensing fees and things come back to Medallion through that process. And yeah, that personally, from an environmental thought, is the best way to work it. But yeah, open to all suggestions. And yeah, so if we look today, then probably the most advanced separation group outside of traditional solvent extraction is in Norway. And Norway are taking that approach, like you say, sort of a toll treating approach. And able to accept material from a range of different locations and then modify their system to do the separation process. And and so that on the way that they're working will work perfectly well. And then outside of that company, there's nobody else doing separation services in that nature. So there is an opportunity for us to be able to be that service provider and give that downstream service.
Well, $50 million-ish is not a huge sum of money for a little micro-cap venture company. It's a good chunk of change. Have you set upon your business model, whether it's going to be your CapEx or whether it'll be a joint venture or just license it out to other people to use and let them use their balance sheet to build out these processes?
Sure. I think, at the moment, certainly, the story may change as we move ahead and talk to new partners. But Medallion doing the first build out, I think makes good sense. And yeah, that can be of an order that suits the market and the customers. But I think us doing it ourselves makes sense in the beginning. And that will be, let's call it project finance. It'll be a combination of of debt and equity. As you say, 50 million is not a great deal, even with a company the market cap of Medallion. And if the project works, if the process works as we believe it does, if we have a permitted site and are committing to that site, then the numbers look extremely attractive. So it's not really a money issue, I don't think. The logic of the process works really well. It will attract the funding it needs, I think, extremely.
Given everyone's fear of being so dependent upon China, or any, like, I don't even want to make this about China, but any kind of single source supplier, like we've all learned over COVID, like when global supply chains work well, they're really efficient, but when they're not working well, they break down pretty quickly, and governments are realizing we need to on-source or onshore key production just on a security basis. And the Biden administration has put not tons of money right now, but tens of millions of dollars to investigate different processes. Do you see, or are you applying for any kind of government funding to help sort of facilitate the process that could be a source of funds for you guys?
Yeah, sure. We've had some government funding in the past, from Canada, and obviously we keep our eyes open for that, and we've made some applications in the past. I think that's it's a smart way to think about it. But if projects are relying on, I guess, the hand of government to be successful, then they've probably got some other fatal flaw and problem that they probably should be addressing internally. And so we're certainly not dependent or reliant on government money or research money. The process and the economics are a standalone and will be funded by their own logic and process. As we look at scaling and we look at some more creative solutions, then absolutely, there's some good ideas that we can cover off in research as well. We're certainly not. It's not a key part of our success or failure to chase money from governments. And the process and the project stands on its own 2 feet without relying on that kind of funding.
Just be a sweetener if it comes through.
Absolutely, and we all like that. That kind of funding pathway, and however, money from governments is never free money. It always comes with limitations and conditions, and so we always give thought to all those proposals that come down the line. The headlines are always positive, but always there's something that is a bit of a limitation on what you're doing. And so we apply for some, we don't apply for all of them, and we've had a few recent sort of applications, and but not chasing. We're not if we get them and they're nice. If we don't, then that's life too. So.
We're going to be hopefully getting some good news out of you in the next couple of months here on your economic study. Can you talk about the coming 12 months, and then as well on a reasonable range of probabilities, what's the earliest, or what do you envision when you could maybe be up in production, or like have some revenues and like there's money coming in, not just going out?
Sure. Yeah, that's the dream of all of us, is to have more money coming in than going out, and less reliant on shareholder funds, I suppose. And so we have the techno-economic study coming out imminently, and we wished it was going to be Q1 this year, but COVID and people in the wrong places, and it just sort of slowed everything down a little bit, which we weren't anticipating. So we're close to that now, and that's going well. So that will provide a very robust engineering model, a robust financial model, and a robust life cycle analysis model. For our internal use, and that allows us then to sort of really be very analytical about where we start to consider operating. So obviously we've got a short list of locations that we think are good, and within that good set, we're looking at 4 ideal sets. So we've done a siting study which came up with West Texas as a good location. So that's one that's on the list. But there's other locations as well that, and I guess the challenge for the US is that, at the moment, there's not a lot of mineral sand being mined in the US. There's not a lot of monazite. So we're looking at some other locations as well, yeah, a little more globally. So really the techno-economic study is the first big tick, and that allows us to compare locations. The next one is to really commit to one location and to begin that permitting process. So we believe our technology is advanced enough, is robust enough, that the rate limiting step really is about the permitting location. It's not really about the technology. So yeah, however long it takes to permit, the technology will be 100% ready by the time we're permitted, because we're very advanced already, and we're only doing the last part. So yeah, committing to that location, and we're talking to some very key sites at the moment. Yeah, is really the major milestone for us, and yeah, we're very optimistic about that in the medium term. We're then looking at sourcing and offtake, and so that's about us getting to know the market a bit better, I guess, for the mineral sand monazite, where that's going to come from. So at the moment, we're working with ANSTO here in Australia, which is the Australian government organisation, and so yeah, big research facility. So ANSTO are world leaders in rare earth processing, lots of experience in mineral sand processing and mineral sand monazite as well, because yeah, a lot of that mining is done in Australia. And so we're now sourcing mineral sand monazite from a range of potential suppliers, doing the processing, doing the characterization of that. So we really know where we want to be, who we want to be talking to at what time, and knowing the value of their material. And as I said, the metal ratios inside the monazite can vary a little bit, not by too much, but yeah, there's a few that are a bit better, and obviously that's the material we'd like to start with. And so location is key. That's really where we begin and end at the moment. Is location is key, and committing to that location, starting the permitting process, and then the engineering will follow behind and be ready when the permitting siting is ready. So revenues, yeah, let's say a number of years out still, but yeah, getting closer all the time. So.
I'm just sort of spitballing here. Let's say you actually, with the economic or the tech economic study you're talking about, and because 43-101 compliant, you can't call it a feasibility or pre-feasibility or that, but is it sort of as detailed as a feasibility study in that scape, or is it more of a general sort of thumbnail?
Well, it's very detailed. Yeah, it's a very detailed study, and yeah, we can't kind of use the crossover of language, but yeah, it's a very detailed study, and yeah, so it identifies yeah, everything we know and everything we don't know, and yeah, and that's sort of part of the reason you do it, is a bit of a gap analysis to see places that you need more data, and so we've done these internally in the past at, let's call them, scoping study levels. And so yeah, to go outside to independent consultants gives us a lot more surety, I suppose, because when you go to an independent consultant, they always ask you about the corners that you kind of knew you didn't quite have enough information. The consultant will come back, and then you've got to make sure you've filled all those gaps, and you've thought about the answer to those questions. And so yeah, we've been through that process now in a fairly rigorous kind of way, and I guess because it's a chemical process that kind of stands alone, it takes away a lot of the challenges that you normally have on a mine site of infrastructure, and where do you build the roads, and the pit, and the water, and the tailings dam, and all of those myriad of complex issues that you face with a mine site. Yeah, for us, if you consider an existing, for example, refinery or something like that, our facility could drop in beside that, and disappear on a very small scale in beside an existing petrochemical refinery, or some kind of other process plant or some chemical plant, and it would be a very, very small part of a site, because it's this is a small footprint process. If we're talking 10,000 tons per year, that's a tiny operation in terms of the mining industry, and so we're not talking about big numbers, because the material is so high grade, and I guess one of the other emphasis I guess I make on the mineral sand process is that we're zero liquid waste. So we don't have a tailings dam. There'll be some solid wastes, and again, it depends on the uranium thorium strategy, but small amount of solid waste, but no liquid waste. So we don't need tailings dams. We don't have sort of big footprints and big impacts. Any waste can go into a drum and be moved off site, very easily. There's no problems there. So our footprint is extremely small environmentally, and I guess thinking of mineral sand, monazite as the mineral, it's 60% rare earths and it's 35% phosphate. So if we make the phosphate a product and we make the rare earths a product, that only leaves about 5% of whatever comes in the door that doesn't dissolve. And so, very small amount of waste we're dealing with, and which means the site is very low, and infrastructure and logistics is extremely simple. So, that was a long answer to a simple question, perhaps, but it's a highly efficient process, and that allows us to be very flexible and efficient.
And you talk about phosphate. Would that be a commercial sellable phosphate product?
Yes, absolutely. Yes, that's a product as well, and so that will go into sort of specialty chemicals or agriculture. The revenues will be maybe 5% of the total. So it's not a particularly high value product, but it's part of that resource efficiency thinking, in that we're transporting it, we're dissolving it. Let's put it to a product, and we're not going to waste anything that we don't want more waste than we need. And if you think in comparison about like a typical, for a low grade rare earth mine that's been considered at sort of 0.5%, where you're only extracting 0.5% of material from the rock. This is so much more efficient and so much more sensible than those processes. And so all mining projects, I think, looking forward, need to think about byproduct strategies and waste efficiency strategies. If we're going to do better as an industry, then that's a key part of the process, and that's going to be designed up front, I think. And that's the beauty of what we're trying to do, is minimizing footprint and being obviously very economic, but also low environmental impact as well. And it's certainly what the industry needs.
Just on the timeline, you said a few years. Would it be fair to say, let's say, first step after the study comes out is what, 6-12 months for a site location, then maybe 12-18 months for permitting, and then maybe 12-18 months for construction? Would that sort of ballparkish kind of be right?
That's ballparkish. And I think as soon as the technical economic study is published, then we're able, perhaps fairly soon after, to sort of start talking very materially with a few locations. So we're not mucking around on that. We're obviously working hard on that already, and with obviously the layer of COVID makes that pretty challenging to not be able to travel to locations that we want to be working. But doing the best we can under those circumstances with local partners, and so we're accelerating that part of the process now. We're well advanced on looking at feedstocks. We understand that market really well. So we haven't ticked that box, but we're well down that pathway, and that's for very large commercial volumes of material as well. So that's going as well as it needs to.
All right. Could you, like, you talked about a 10,000 ton facility, I believe, that, like, just sort of as an example, in terms of tonnage, what is the tonnage of, and you're largely looking at the magnetic rare earths, either the magnetic rare earths, the global market, or the entire rare earth spectrum market. What is the tonnage of that annually?
So if we have 10,000 tons of mineral sand monazite, and I won't do the maths for you, I'll allow you to do your own maths, but if we have 10,000 tons of mineral sand monazite, then about 60% is rare earths. And 35% is phosphate. So that gives you the numbers of what comes out the
so 6,000 tons of rare earths come out of that.
Of rare earths is what we produce. Then within that 6,000 tons, the NdPr, the magnetic metal component, is anything from 15 to 25%, something like that. So depending on the sourcing of the mineral sand monazite. So in particular, we're focused on neodymium, praseodymium, dysprosium, and terbium. And I guess one of the reasons, so that's where all the value will sit. So so neodymium and praseodymium at the moment, say $80 per kilogram. So you can kind of do some maths there on the revenues that come out of it. But I guess one of the beauties of why we chose the Purdue process with separation is that with a lot of separation technologies, you need to go through like a let's think of a Christmas tree or something like that, where you do group separation and you gradually separate all your materials. What we're working on with the Purdue process is the direct separation of the most valued materials, and so we can take the NdPr early as a group and get a marketable product very, very early in the separation process. And we can then precipitate other materials and sell those to other customers and things, but we can grab the NdPr without going through a really complex set of separation, and that's where some of the real power lies within the process they've developed. So we're very focused. Certainly, and again, very rough numbers, back of the envelope, and very price dependent, but the magnet metals will be 90% of the process value, something like that. So we're very focused on the magnet metals, which is great because it's a booming market. It's got 15% annual growth. At the moment, essentially everything is coming from single source from China, and which at the moment is working kind of okay, but as the market demand grows, it's going to stop working okay. And so that's where alternative sources outside that monopoly need to come through, and Medallion will be absolutely a first mover in that kind of marketplace.
So on your 10,000 ton facility, if I did the math quickly, that's like 1,000 to 1,500 tons of the NdPr coming out of that. Is that like 1% of the global NdPr market, or 5%?
No, more than that. So so the global market, at the moment, say, if my numbers are right, about 35,000 tons, something like that.
Oh, okay. All right. So 3-5% sounds like somewhere in that.
Exactly. So we're we're not going to distort the market. We're a substantial producer, but we're not going to distort the market. And then we can look at 10,000 ton modules, I suppose, as the market demand grows. And as you know, with rare earths, we're talking about an industrial product. So really, you need to have your customer worked out before you begin the process. It's not like copper or gold where you sell into London Metal Exchange or something like that. So as the customer grows, then the production grows, and if those things are out of sync, then the industry really struggles. Either the price goes far too high, as we've seen in the past, or there's a glut, and both of those are a problem. So we need to make sure we've got surety of where the materials will go before we sort of make really large commitments. So at each increment that we grow out, then we'll be in a position to sort of have the customers in place before we make those commitments, and ourselves or the partners as well will be the ones that do those scale out financings.
But when you do have your offtake, that's a leverageable asset, and then that can help your funding of the project going forward.
And certainly from our discussion with the downstream at the moment, that volume of material we're talking about would sell within a heartbeat. There's a very strong demand for those materials. I think everyone appreciates that. We've kind of past the tipping point, past the curve on EVs and on wind energy, and as those things scale and grow out, then the demand for raw materials is enormous, and rare earths is one of those materials, and so we're past that tipping point now, and I can't call it a panic in the market, but there's some urgency in the market that I think customers are realizing from major automotive firms that they really need to get their 5 and 10 year resourcing strategies worked out. And I'm sure, like many of us, we follow Benchmark Minerals Intelligence and other suppliers of technical data that sort of show just the gap in the market between what the mining industry is currently providing and what the promises that have been made by the automotive industry. And in battery and rare earth metals, and yeah, the gap is huge, and so there's going to be a lot of pull through in demand as those scale out, or companies, the Teslas, the Volkswagens, the Daimlers of the world won't be able to hit their targets because they don't have access to the raw materials.
We should wrap it up here, but I guess one final question is, can you talk about your balance sheet, your burn rate, and your runway here? How is all that looking?
Sure. No, the company's in a pretty robust kind of state, and yeah, so we've got around $2 million in the bank. We've had a good run of money coming in through exercise of options and warrants over the last 6 months. So yeah, it's nice as a CEO when you see most months the money has gone up rather than down. It's kind of a rare pleasure, I must say. So yeah, we're in good shape, and so yeah, at the moment, most of our financing is going into the technical economic assessment. Plus, we're doing physical test work in Australia at Anstone. Yeah, both of those are reasonably well funded already out of our what we have, and so it's not drawing too heavily on our reserves. We're a pretty small company, and so pretty nimble. So our cash burn is very modest. So yeah, we're not sort of on the path of financing at the moment. Yeah, always interested to talk to partners and ideas, but yeah, there's certainly no imminent need for financing.
And your runway, would that be like 6-9 months or over 12 months?
Over 12 months, yeah, absolutely over 12 months, yeah.
Okay. All right. Well, with that, we should wrap it up here. Mark, thank you very much for taking the time to talk with us. It's very in-depth and interesting, and a lot of information there. So if you have any final comments, thank you very much.
No, my pleasure, Martin, and yeah, thank you for the opportunity. And yeah, like it's an industry that's very close to my heart, and yeah, I can talk for a long time about it. So anyone that wishes to get in touch, then yeah, drop me a message, and yeah, very happy to follow up at any time.
All right, Mark. Thank you very much. Have a great day. Cheers.
Okay, thanks, Martin. You too. Cheers.